Assalamu alaikum. My name is Arshabari Khurshid, and I'm going to present my project line follower. My group members are Muhammad Usama, Muhammad Dalal, Umar Farooq, and our instructor is Sir Umar Farooq. Table of contents of my topic are my project, our project report, our problem statement, objective, task, scope, component, schematic, block diagram, PCB and 3D design, hardware, codes and work division, and expected outcomes and conclusion. Problem statement is design and build Rehaber, the line following robot that must follow a random given path on a planet with a black and white surface using infrared sensors using a range of resources while also detecting obstacles, distant colors, while also utilizing voltage and current sensors along with a speed encoder on each motor. Objective of the project was to develop a comprehensive solution for enhancing the functionality of a line following robot by integrating Bluetooth controls and Wi-Fi capabilities using an ESP32 microcontroller. The system should also incorporate on LED LCD display, 0.9-inch screen for real-time data visualization. Additionally, it should include a voltage sensor, a current sensor, and a speed encoder all interfaced with the ESP32 to provide accurate reading display on the OLED screen. Furthermore, the project requires the utilization of an Arduino Nano microcontroller to control a motor driver L298 and manage inputs from 5 infrared IR sensors. The primary function of this setup is to facilitate the robot's movement along black lines detected by the IR sensors. The Arduino Nano should interpret signals from these sensors and adjust the motor's speed and direction accordingly. Moreover, the system must integrate a color sensor for detecting different holes along the path and an ultrasonic sensor to identify the obstacles in the robot's vicinity. These additional sensors should provide real-time feedback to the ESP32 microcontroller, enabling the robot to adapt its course dynamically based on detected colors and avoid collisions with obstacles. The overall objective is to create a versatile and autonomous line-following robot capable of navigating diverse environments with minimal user intervention. This entails seamless communication between various components, precise sensor readings, and efficient motor control mechanisms. The project aimed to demonstrate the feasibility of incorporating advanced features into a line-following robot, thereby expanding its utility in practical applications such as warehouse logistics, automated guide vehicles, and educational robotic platforms. The task is ESP32 controller Bluetooth control input Bluetooth communication protocol to enable remote control of the project via a smartphone or other Bluetooth enabled devices. Wi-Fi capability. Figure the ESP32 to control a Wi-Fi network, allowing for remote monitoring and control over the internet. OLED LCD display interface ESP32 with the 0.96-inch OLED display to visualize real-time data such as sensors reading, system status, and control options. Voltage sensor connect and calibrate the voltage sensor to accurately measure the power supply voltage of the robot's battery. Current sensor interface the current sensor with ESP32 to monitor the electrical current drawn by the motors and other components. Speed encoder utilize the speed encoder to measure the speed and direction of the robot's movement and display this information on the OLED screen. Arduino Nano microcontroller motor control program the Arduino Nano to control the motor driver L298N based on inputs received from IR sensors. Adjust motor speed and direction to flow back lines directed by the sensors. IR sensor integration interface the Arduino Nano with 5 IR sensors to detect the presence of back lines and provide feedback for motor control. Integration with the ESP32 establish communication between the Arduino Nano and ESP32 microcontrollers to exchange sensors data and coordinate motor controls. Actions. Additional sensors. Color sensor integrate the color sensor with the ESP32 to detect different holes along the robot's path. Uses information to adjust the robot's behavior or trigger specific actions. Ultrasonic sensor connect the ultrasonic sensor to the ESP32 to detect obstacles in the robot's vicinity. Implement obstacle avoidance algorithms to steer the robot away from the potential collisions. Overall system integration. Data fusion combine sensor data from all components: IR sensors, color sensors, the ultrasonic sensors, the voltage sensors, current sensor, speed, and encoder to create a comprehensive understanding of the robot's environment and status. Control logic, develop control algorithms to interpret sensor data and make decisions regarding motor control, path following, obstacle avoidance, and other robotic behavior. User interface, design a user-friendly interface on the OLED display to provide real-time feedback, status updates, and control options for the user. Testing and optimization, conducts through testing to ensure the reliability, accuracy, and efficiency of the entire system. Optimize in algorithms and parameters for optimal performance in various operating conditions. By breaking down the implementation into the distinct tasks for each component, you can focus on developing and integrating each part separately before testing and optimizing the complete system. Scope the component selection, choosing appropriate components including the Arduino microcontroller, IR sensors module, and display unit. Circuit design and assembly, designing and assembling the electronic circuit to interface the IR sensor with the Arduino and other components. Programming, developing the software to process sensor data, conclude RPM, and display the results. Calibration and testing, calibrating the tachometer to ensure accurate measurements and its testing under various conditions to verify its performance. Components: Arduino microcontroller, Arduino Nano R3. Description: a widely used microcontroller board with Apple digital and analog input-output pins, suitable for prototyping. Operating voltage 5V. Digital input-output pins, 14 of which 6 provide PWM output. Analog input pins, 6 IR sensor module. Motor IR sensor module, example KY032. Description: an IR sensor module capable of detecting rational speed by counting interruptions or affections. Operating voltage 3.3V to 5V. Output: digital signal. Display unit, model 16x2 LCD display with 12C interface. Description: a liquid crystal display to show the RPM readings. Operating voltage 5V. Interface 12C reduces the number of pins required for connection. Power supply 9V battery with battery connector. Resistors and capacitors. Resistors 220 ohm resistor for current limiting and LED indicators. 10k ohm resistor for pull-up pull-down configuration. Capacitor 0.1 microfarad ceramic capacitor for power supply stabilization. Breadboard and jumper wires. IR reflective tape or marker. Description: reflective tape or a marker to create constructing patterns on the rotating object for the IR sensor to detect. 0.9-inch OLED resolution, typically 128 x 64 pixel, providing clear and detailed display. Interface often uses 12C or SPI for communication with the microcontroller. Encoders. Encoders type can be rotatory or linear, used to measure the position or speed of a rotating object. Output provides digital pulses indicating movement, which can be counted to determine position or speed. L298 motor driver, dual edge bridge capable of controlling 2 DC motors or one stepper motor. Current capacity can handle up to 2A per channel, suitable for medium-sized motors. Micro SD card modules. Storage expansion allows for data logging and storage. Capable for micro SD cards up to 32 GB. Interface communicates via SPI, easy to interface with Arduino or other microcontrollers. Voltage sensor can measure voltage typically 20 to 25 in output. Analog output voltage proportional to the input voltage, used for monitoring battery levels or power supplies. ACS712 current sensor, measure current measurement, available in different ranges, example 5, 20, 30 ampere for current measuring flow. Output: analog voltage output proportional to the current being measured, useful for power monitoring. TCS3200 color sensor, color detection, can detect and measure RGB colors using an array of photodiodes with color filters. Output provides frequency output proportional to the intensity of the detected color, used in applications like color sorting. Miscellaneous components, connectors and headers. Pin headers for making connections between components. Switches, push buttons or toggle switches for user inputs, example start stop measurement. LED indicators, optional LEDs to indicate power status or operational status. The next is the schematic diagram of our project. Here we use Arduino Nano ESP32 microcontroller L298 mini 0.93 in OLED display, eye sensors array, color sensor, microcontroller, SD card adapter, current sensor, voltage sensor, um, a nano header, ESP32 head pins. We use color sensors, current sensors, voltage sensors, and this is the block diagram of our project line follower. This is the 3D design of our project. And this is the PCB diagram. Both the schematic and PCB were done on the software EasyEDA. This is the hardware diagram of our project line follower. This is the code for ESP32. How we have set pins and the values for each sensor that was connected or the ESP was giving signal to. And this is the code for Arduino Nano, and here we have selected pins and functions and the sensors that the Arduino Nano was giving signals to work. Setting values for the motors and the positions using simple C language. Motor speed, left and right positions and their speed, on which speed should it move. Work division, my work was the hardware implementation and report, and secondary works were component research, circuit design and coding. Osama's primary work was circuit design and hardware implementation, and his secondary works were component research, report and coding. Talal's primary work was component research, coding, and his secondary works were report, hardware implementation, and circuit design. And Omar's primary work was component research and hardware implementation, and secondary work was report, coding, and circuit design. As whole project work was done by all of us, and everybody has part in each hardware, coding, or software and PCB design. We work together in every work. Expected outcomes were, upon successful completion of this project, will have a functional ESP and Arduino based robot capable of accurately measuring and displaying the RPM of rotating motors, along with color sensing, line following data, displaying on an LCD, voltage and current sensing, and storing in an SD card. The device will be user-friendly with clear instructions for assembly and operation. The knowledge gained from this project can be applied to further development and enhancement of robotic devices, potentially leading to more advanced and specialized applications. And the conclusion of conclusion basically the development of an all-in-one robot incorporating color sensing, voltage and current sensing, or an OLED display for value readouts, motor RPM measurement with encoders and data storage on SD card demonstrated the powerful capabilities of combining an Arduino Nano with an ESP32. This project showcases how these versatile microcontrollers can work together to create a comprehensive system for monitoring and controlling various parameters. This was a short presentation on our project, the line follower. This is my LinkedIn account where I've post my pictures of my project, line follower. These are the pictures, the hardware form. This is the PCB picture of PCB design picture of my robot line follower. This is the 3D design photo, and this is the schematic showcasing every component that I have used and its positions and how I named every and each pin. Again, this is the hardware picture. So this is my LinkedIn account where I've posted about my all-in-one robot line follower, and this is my GitHub account. Where I've posted everything about my this first project, line follower. It's a 3D design. The 3D design of my project. The Arduino Nano code. Full code for the Arduino Nano chip that I have worked on and used it on my chip, and this is the ESP32 code for my line follower robot with every and each calculations that I have done, accurate code that I've done. This is the code for ESP32 and this is the Gerber line follower new PCB zip file. This is the zip file. This is the hardware picture. I also posted this on that. This is the license for my account, permission license, limitations, and all of the stuff. Each and every rule is written on it. And this is the PCB design of my line following robot on GitHub account of my GitHub account, and this is the instructions and the problem statements and objectives and all the things and the components that we have used it, and the expected outcomes and conclusion, every information about the robot. This is the schematic diagram of how I have designed. Our group have designed this robot using these components with all this structure and composition of our circuit. So this is my LinkedIn account, and this is my GitHub account, and this was a small presentation